Hello everyone, and welcome back to my series in C++. Today's topic, we're going to look at templates. Templates is a feature in C++ that allows functions and classes to operate with generic types. Templates are like stencils. So this allows a function or a class to work with different data types without being rewritten for each one. They are defined in a header file or just above the function or the class. So a function template and class template specialization are instantiated at compile time. For a function template, a programmer can write a single function definition, and compiler generates separate object code function based on the argument type in the function call, and that is called function template specialization. To start off with function templates, I'm going to create a function, and I also want using namespace. I'm going to create a void function, and the function is going to call print data. And just above the print data function, I want to declare this function as a template. So I'm going to use the keyword template. And inside of anchor brackets, type name. Right beside type name, you put a T. You can put whatever letter you want, but for conventional reasons, a lot of programmers use T to denote that this function is a template. So inside of the print data parameter, I'm going to declare a const, and it's going to be from T data type. It's also going to be a pointer, and I'm going to call this variable data. And I'm also going to declare an int called count. Inside of the function, I'm going to create a loop. It's going to be a for loop, and I'm going to declare int I, and I'm going to initialize my I variable. So my I is going to be the counter that goes through the loop, and I want to say as long as I is less than count, which is my count variable in the function parameter. I also want to increment I as long as I is less than count. So inside of the for loop, I just want to print the data. So this is a very simple function, and data I, and I'm going to end the line. That's all for this function. So I'm going to declare my main, and inside of main, I'm going to declare 3 variables, and they're all going to be const, and I'm going to call this a count. And a count is going to equals to 5. And I also want a const, also an integer called b count. Also going to initialize this one to 5 as well. And this one is going to be c count. I'm going to initialize it to 6. So these 3 variables are the size we're going to pass through the print data function. And I declare it const because I do not want the data or the size to change or modify. So in C++, when you use the const keyword, that means that this variable cannot be modified throughout the program. So I'm also going to declare 3 other integers. So they're going to be int. This one is going to be a. And for a, we're going to give it a count. And this is my array, and I'm going to just put simple data 1, 2, 3, 4, and 5. And I'm going to declare a double, and this one is going to be b, and the size of b count. And I'm going to give this b variable 5 double. So I'm going to put 1.2, 3.4, 5.6, 6.7, and 7.8. And I'm also going to declare a char or a car, and it's going to call c, and I'm going to give it the size of c count. So I have 3 different variables with 3 different data types. So a is going to get the size of a count, which is 5, and I initialize 5 integers, and b, which is a double, going to get the size of b count, which is also 5, and I also initialized 5 doubles. And I have a char or a car named C, and I initialize it to the size of C count. So C count is 6. So now we're going to use the function template we have created above, which is a single template, and it's going to print the data of all 3 different data types. Before I use the function, I'm going to write a statement, and the statement is just going to be simple, different data types, and I'm going to use the cout statement again, and I want to print a count data. So and I'm going to call the print data function. And inside of the print data function, I'm going to call a, which was declared at line 20. And I also want to call a count as well, which is the size that I have declared at line number 16. And this one is going to be b count data. And I'm also going to call the print data function. And for this one, I want to call b and b count. So last one, I'm going to call c count. And I'm going to call the function print data. This time I'm going to pass in c's data and c count, which is the size. And I want my return statement. So let us build and run the program. So here you have a count data, which was an integer, and then we have b count data, which are doubles, and we have c count data, which are characters. And all of these different data types got printed using a function template. Let's take a look at class template. So let's declare a class called calculation. Same as the function template, you have to declare template above the class declaration. So we're going to use the keyword template. Instead of the calculation class, let's define some private variables. And it's going to be of t data type, and I'm going to call this variable a. And the second one is going to be of t data type as well, and I'm going to call it b. Let us also declare some public methods. And first I'm going to get the constructor, and I'm going to declare 2 variables inside of the constructor. So one is going to call a and the other is going to call b, and they are of t data type. I'm going to declare 2 methods. So one is going to call addition, and the other one is going to call subtraction. At the bottom of the class template, I'm going to define the functions. Let's use the keyword template again. Let us get the constructor. So it's going to be calculations, and then you have to use the T right after the class name inside of the anchor brackets, and we want to access the constructor. So the constructor is the name of the class, so it's going to be calculation, and we want T, A, T, and B. I'm going to initialize the private variables that is inside of the class to the variables that is passed through the constructor. Let us define the addition method, and we still want to use template keyword above the function name and say T. For this one, you also have to put the T variable in anchor brackets right after the class name, just so we can access the methods or the data inside of the class. And for this time, we want to access the addition method. And inside of the addition method, I just want to make some simple calculations. So I'm going to declare a variable called sum, and sum is going to equals to A plus B, and I want to return sum. Very simple function. And let's do the same for subtraction function as well. So we also need the keyword template above, and in the bottom is going to be of T data type, and we want to access the subtraction method. The subtraction method is basically doing the same thing as the addition method, but we're just subtracting. So I'm going to declare a variable called sum of T data type, and sum is going to equals to A minus B, and then I just want to return the sum. This is all for the function declaration and definition. So let me create a main method to call the functions. And inside of main, let's create some objects. So to create objects, you have to use the name of the class. And templated objects are a little bit different from regular objects. Regular objects, you just call the name of the class and the name of the object. But for templated object, you have to use the data type that you want to create or instantiate. For this one, let's use int data type, and we're going to call this int data. And inside of the int data, we want to pass 10 and 5. And then let's do a simple cout statement, and we're going to say int data type, and let us call the function, and we want int data dot, and let us call the addition function. Let's do a next cout statement again, and this time we want to call subtraction. Let's just end, and let us create a second object, but this time this object is going to be of double data type, and we're going to call this one double data. And inside here, let's put 20.25, and let's put 5.50. So let's change this data type so it can be camel case, and let's do some cout statement. So this, we're going to say double data type, and let us call the functions double data dot, and we want to access the addition method. Let's do a next cout statement to get the subtraction method, and we want the subtraction method. And let's do one more, and this one is going to be for floats, and we're going to call this one float data. And inside of this, let's do 25.56, and let's do 10.5. I spelled this word wrong, so this is going to be CCAL. There goes my spelling. And let's do some cout statement for this as well. So we're going to say float data type, and we want to access the addition method, and let us access the subtraction method as well. Let's do and that's all for the main. So let us build and run. And here we have the different data types with the results.